Hello, sixth graders. So today we are going to start topic 1.5, and it's all about evaluating algebraic expressions. So I mentioned the word algebraic expression yesterday in our lesson, or the other day in our lesson, and now I just kind of want to go over the definition of an algebraic expression. So we talked about numerical expressions before. That was when we did order of operations, okay? Now we're doing algebraic expression. And it's basically the same thing as a numerical expression. It's like a number sentence, okay? But the algebraic part of it is that it has variables in it now. So the definition of an algebraic expression is a mathematical sentence that has at least one variable and one operation. And by operation, I mean addition, subtraction, multiplication, or division. So today, we're going to evaluate algebraic expressions, which means solving them. So to evaluate an algebraic expression means to find the value of it. Okay, so we're solving an algebraic expression. But remember, if you notice, if it has variables, that means that we have unknowns. So to evaluate an algebraic expression, basically, we are given the values of those unknown variables. So given the specific values for each variable. So first it says blank the given value for each variable. Okay, so for example, what I mean by that, if we have the expression x plus 4, there is no way we can solve x plus 4 because we do not know what x is. There's no way we could solve it. But let's say that we were given what x equals, or what that variable equals, and we were told that x equals 2. Well, now that we know that that unknown is actually known, what we can do is plug the value of that x, which is 2, into the expression. And we can solve it. So it will be 2 plus 4. Okay? So the first step is the word is substitute. Okay? Just like we have substitutes in school who take the place of a teacher, when we substitute in that value, it takes the place of the unknown and we actually know it. So you substitute the given value for each variable, aka plug it in. Plug in that 2, okay? Step 2 is evaluate the numerical expression using blank of blank, okay? Now, we did this earlier a few topics ago, okay? What is the order? It's called the order of operations. So that is parentheses first, exponents, multiplication and division in the same step, okay, addition and subtraction in the same step. Or you may have seen it as PEMDAS, okay? So let's look at the second slide. It says, evaluate the expression when A equals 5 and B equals 2, okay? So remember, okay, we didn't know what A equals or what B equals in our expression. However, now we are told, someone came to us and said, hey, look, A now equals 5 and B now equals 2. So we can plug in 5 and 2 in for their corresponding variables and solve. So this is the expression that we're given, 5A minus B. Okay, so we originally did not know A or B, so we couldn't do anything. But now they say B equals 2 and A equals 5. But there's a big remember, 5A when we have a coefficient, which is the 5, and a variable smushed together, that stands for multiplication. So it looks something like this when we solve it. We plugged in that 5 in for A, plugged in that 2 in for B, and now we have 5 times 5, which is 25. We do that first, then we subtract the 2, and we get 23. Okay, so all you're doing, we're given the values, you're just plugging them in. So let's do one more together, and then I'm going to have you do these next two on your own to try them out. So you're going to evaluate all three of these expressions when r equals 3, p equals 7, and x equals 2. All right, so on a scrap piece of paper, we're going to do the next one together. So it's 3x plus, I forgot that already, 7 minus r. All right. And it's when r equals 3, p equals 7, x equals 2. r equals 3, p equals 7, x equals 2. So right now, there is no way we can solve this problem unless we know those values, okay? And luckily we do because they're written right here, okay? So x is 2, so we can plug in 2 for x. R is 3, so we can plug in 3 for r, and we're going to rewrite the expression. So it's 3, and now again, we have a coefficient and a variable smushed together, which stands for multiplication. So it's 3 times x, which we just found out was 2, plus parentheses 7 minus, we know r is 3, so that's not an r anymore. Now it's a 3. And now we can just solve using order of operations. So we'll do the parentheses first, because that's what comes first in PEMDAS. 7 minus 3 is 4, excuse me. Rewrite the whole thing again. Again, multiplication comes first. 3 times 2 is 6. 6 plus 4 is 10. And 10 is our answer. So we can write 10 in this spot right here. Now what I want you to do is to try the next two on your own. So give it a go and see what you can do on a scrap piece of paper. So we have 30 minus 4p plus x parentheses r. 4p plus x parentheses r. So I know already that the x and the r are being multiplied. And same thing with the 4 and the p. Coefficient variable smushed together, multiplication. 2 variables with parentheses, multiplication. Okay, so the p is 7. So that is 7. The x is 2. And the r is 3. It's almost like we're given a code to solve this. So now let's rewrite the problem. It's 30 minus 4. And again, these two are being multiplied. So I'm just going to put that in a parentheses and write 7 there, because that tells me I still multiply them. Plus x is 2, r is 3. And now I solve. 7 times 4 is 28, plus 2 times 3 is 6. And bring down that 30, okay? Remember, rewrite everything. 30 minus 28 is 2 plus 6, and our answer is 8, okay? So for that problem, it is 8. And then this last problem, it looks tricky, but again, write it out, try your best. This sign right here, you can't type division on Google Slides, so that slash basically just means division. So it's, let's see, add another piece of paper. Okay, it is brackets, 6 parentheses, p minus x plus 6 brackets divided by 2. Okay, and P is 7, X is 2, and R is not in this expression. So let's solve it. Rewrite the whole problem with that new information for the unknowns. We have 7 minus 2 plus 6 brackets divided by 2. So we're going to solve, remember, we talked about this the other day, working our way inside and working our way towards the outside. So we're going to solve the 7 minus 2 first and get 5, but that's still in parentheses, okay? And the 6 goes there. So what does that stand for? 6 parentheses 5. We know we're multiplying. We add the 6 and divide by 2. I rewrite the whole problem. Now we do 6 times 5 is 30 plus 6 brackets divided by 2. We have 30 plus 6 is 36 divided by 2. 36 divided by 2 is 18. And that is our answer, okay? And again, just like before, it should look like a slice of pizza. So I personally enjoy these problems because it's almost like you're solving a riddle. First, you have the clues to what the unknowns are, and then you're doing order of operations with those unknowns. So this second half, once you have it already written, is very similar to what we were doing the other day, okay? The only new part is now we're given an expression that is algebraic, which means it has variables in it. But luckily, we are given the values of those variables, so we can substitute or plug in those values and then solve using order of operations. All right, so attached to this Edpuzzle is going to be a Google form with some more problems for you to practice substituting in values for certain variables and solving. All right, email me if you have any questions.